The module test, see it here? You see where this come from? See it?
Oh, yes, I see it.
All right, this was taken from 2008, all right? 2008 paper. All right, now this says now P is equal to I minus J and Q is equal to lambda I plus 2J. Find the values of lambda such that Q is parallel to P. Now, Marika, what you have to remember is if two vectors are parallel, then that means they never intersect. That means the angle between them is 0. So if P look like this, then Q look like this. That's the only way two lines parallel if them have same gradient. But if them parallel, there's no angle between them. There's no angle because they never intersect. So that's what we're going to use to find this now. All right. So let's write down what they tell us for P. All right, this is if they're parallel. So let me put the direction to show the two of them parallel. Now, them tell us that P equal to I minus J. All right, so in other words, Marika, we're going to write P in a form that is better to us, which is 1 minus 1. In vector form, it's a lot easier to write it that way. Then they tell us Q is lambda I plus 2J. Q is equal to lambda I plus 2J. That them tell us is Q. So if this is P and this is Q, writing Q in this form, Q is lambda 2. Now, Marika, remember that as I said, if two vectors are parallel, then the angle between them is 0. So let's write that out for part I. If two vectors are parallel, the slash mean parallel, this mean parallel, then the angle between them is 0. So now, Marika, if the angle between them is 0, this is what we do now. If the angle between them is 0, then that means if you were to set up the formula, Marika, that means that the cos of the angle is 0 is equal to P dot Q over the modulus of P times the modulus of Q. That's what we're going to use to find lambda. The cos of 0, because the angle is 0, the cos of 0 is what? The cos of 0 is 1. So 1 is equal to P dot Q. Let's work out P dot Q. P dot Q is going to be 1 minus 1 dot Q is lambda 2, and that is over the modulus of P. The modulus of P is the square root of 1 square plus minus 1 square. That's the modulus of P. And that's been multiplied by, this is now multiplied by the modulus of Q. The modulus of Q is lambda square plus 2 square. Lambda square plus 2 square, which is 4. All right, so we're going to finish it off up here. So following that now, Marika, 1 is equal to, working out the dot product, it's 1 times lambda, which is lambda minus 1 times 2, that's lambda minus 2 over 1 plus 1 is 2, so that's the square root of, I'm just going to put it as one big square root. 1 plus 1 is 2, 2 times lambda square, so that's 2 lambda square plus 2 times 4 is 8. All right, all I did was join these two square roots. Square root of A times the square root of B, the square root of AB. So we need to find lambda now, Marika, so we can cross multiply. So we have the square root of 2 lambda square plus 8, and that's equal to lambda minus 2. So what that then means, Marika, is when you square both sides, you'd end up get 2 lambda square plus 8 is equal to let me put in words what we're doing. We're squaring both sides here. Squaring both sides. Squaring this side, you're going to end up get lambda square minus 4 lambda plus 4. That's what you end up getting. So now all we end up with is a quadratic. So you can actually just bring over lambda square over here to write lambda square. Bring over the minus 4 lambda over here to get plus 4 lambda. Bring over the 4 to that side to get over here, go and then make it be plus 4 equals 0. Solving this, Marika, we can factorize it. We're going to end up get lambda, lambda, 2 and 2. Signs are the same, both of them positive. So this is a plus, and this is a plus, and this is equal to 0. So what we end up getting is that lambda is equal to -2. Lambda is -2. Nice. So this is the value of lambda when there are parallel. Lambda is -2. Now I know what you're saying. You're probably saying, sir, 1 mark it worked. But that's the thing. Because it's the same principle, it's really 8 marks to doing one, you know. Because look, Marika, now we're going to find where Q is perpendicular to P. Now we already know the dot product. We already know the magnitude of P and the magnitude of Q. All we have to do is set the formula now equal. The dot product is 0. The dot product is 0 when they're perpendicular. We already know the dot product. We already set up the angle formula, so we can set the angle formula equal pi by 3 for part 3. So even though this were 1 mark, what they did was take into account the next 2 questions that we're going to follow using the same principle. So that's why they distribute the marks like this right here. All right, make sense?
Yes.
Oh, right, -1 when it should have been -2. Sorry, let me change this. It should have been -2 here, so. All right, parallel when lambda is -2. Now we need to find the value of lambda when they're perpendicular to each other. So as I said, 2 vectors are perpendicular when their dot product is 0. So P and the Q are perpendicular when P dot Q equals 0. That's when 2 vectors are perpendicular, when P dot Q is equal to 0. All right, now this was P dot Q. Already work out P dot Q. Don't it? Now this P dot Q is lambda -2, right?
Yes.
See the P dot Q lambda -2. So that's why I'm telling you that don't look at 2, the other one is 1 mark. So now this is just lambda -2 equals 0. And so in this case, lambda equal 2. All right, so that's the value of lambda when they are perpendicular. Lambda equal 2. Now we can look at part 3. And of course, I feel like I'm going to prove all of them to you using the geometer sketch, but I'm going to show you that they're indeed true. So so this one, lambda equal +2 in this case. Now this one says the angle between P and Q is pi by 3. So all we're going to do, Marika, is instead of set the angle to be 0 in this formula, set it to be pi by 3. So then now, when the angle between them is pi by 3, we know that the cost of pi by 3 is going to be equal to, we already know P dot Q is lambda -2. It's lambda -2 divided by, we already know the magnitude of P times the magnitude of Q. It was the square root of 2 lambda squared plus 8. 2 lambda squared plus 8. Now the cost of pi by 3 is cost of 60. I think the cost of 60 is a half. All right, you can verify for me. I think that's a half. The cost of that is a half. So we have a half is equal to lambda minus 2 over the square root of 2 lambda square plus 8. Then now we can cross multiply, Marika. We're going to cross multiply. So what we're going to end up getting is, when we cross multiply, we get the square root of 2 lambda square plus 8. We get that is equal to, this is now 2 lambda minus 4. And then we can square both sides to end up get 2 lambda square, plus 8 is equal to, I always forget to write that we're squaring both sides. You have to make them aware of what you're doing, squaring both sides. All right, so that will then be 2 lambda square plus 8 equal to, this is now first term square, 4 lambda square, minus twice the product of the 2. 4 times 2 is 8, so it's minus 16 lambda plus 16. Bring everything to one side, bring over 2 lambda square over here. So put 0, bring over 2 over here to get 2 lambda square. Bring over, so this is still minus 16 lambda. And then bring over the 8 over here, and that's just plus 8. So now, Marika, we can divide through by 2 to end up get a simple quadratic, lambda square minus 8 lambda plus 4. Lambda square minus 8 lambda plus 4. Can this factorize easy? I hope so. Signs are the same, both of them negative. Which two number one it? All right, that's going to take me a while. So what I'm going to do is just go straight to quadratic formula. Lambda is equal to minus b plus or minus the square root of b squared. 8 squared is 64 minus 4ac minus 4 times 1 times 4, that's minus 16 over 2a, which is 2 times 1, which is 2. So I end up get lambda is equal to 8 plus or minus 16 minus 64 minus 16 is 48. So that's the square root of 48 over 2. But the square root of 48 can be simplified. Let's just simplify it right here. Root 48 is, that is what, 24 times 2? How can I break this down now? Root 48, that's the root of 16, good. Root of 16 times the root of 3. But the root of 16 is what, 4. So end up get 8 plus or minus 4 root 3 over 2. So I'm just going to write the final answer right under here. So for part 3, the possibility is that lambda can equal to 8 over 2, Marika. 8 over 2 is 4. So that's 4 plus 4 over 2 is 3. So it's 4 plus or minus 2 root 3. That's the possible values for lambda. 4 plus or minus 2 root 3. All right, that's the last one. All right, so we write that down. Lambda is equal to 4 plus or minus 2 root 3. Cool it is, Marika?
Yes, sir.
Cool it. Now, Marika, I'm gonna just show you I'm gonna show you it on the graph, just so you can see that it makes sense. All right. I just like also vectors on graph because I really like vectors. So I'm actually going to show you when of course lambda is the different values. All right, so the program just freeze again. Let me close some more programs. Close this. Close this tab. Close this tab. right, so I'll close all of the tabs. This should do it. GSP5. All right, it's not computer behaving a little bit today. So I'm just gonna continue with the worksheet. Let's just continue. All right, so the next question said we're supposed to prove that 1 minus cos 2a plus sine 2a over 1 plus cos 2a sine 2a equal tan a. So talk me through it, Marika, since this is the module question. I want you to talk me through it. All right, you're gonna talk me through it. All right, so talk me through it, Marika. No. Yeah, so we start with our left-hand side. Yeah, talk me through it. Are you hearing me, Marika?
Sir, come. The cos 2a would be 1 minus 2 sine squared a.
All right, so the cos 2a become what?
Minus 1 minus 2
2
sine
sine
squared.
squared a. All right, 1 minus 2 sine squared a. Good. 1 minus 2 sine squared a. Good. All right, now I'm asking you, why did you make this substitution? Why did you use that substitution, Marika?
Trying to get sine over cos.
Good, good, good. Because we're trying to get sine over cos, you want to put a sine in the numerator. So now we use the cos substitution in the denominator, don't we? So we use the 2 cos squared a minus 1. Good. Nice. I just did want to see if you remember what to do. All right. Nice. All right. Good. So thank you for that. So now we can quickly finish it off. We know if we were to expand in the bracket now, 1 minus 1 gone, minus and minus cancel. So we end up get 2 sine squared a plus sine 2a. But we know that sine 2a is, of course, 2 sine a cos a. And then in the denominator now, we know that the 1 minus minus 1, 1 minus and minus. So now what we're going to end up get is, oh, this was a plus. Oh, that was a plus. That would have ended up become 2 cos squared a plus, we know that the sine 2a become 2 sine a cos a. Nice. And then, of course, now we go back to our basic principle, factorization. Remember what I told you? Factorization is the process of completely distributing two unlike terms with a common factor. And so the common factor that we know, it is 2 sine a. That's in common. We factor out 2 sine a from the numerator, and we're left back with
sine a plus cos a.
Sine a plus cos a. Good. Nice. Sine a plus cos a. And in the denominator, realize that the common factor is
Cos a, 2 cos a.
2 cos a. 2 cos a. You are absolutely right, Marika. And then we're left back inside with sine A plus cos A. Well, actually, let me write it properly. You're actually left back with cos A plus sine A. Just for the semantics of it, you have to say cos A plus sine A. And then we know that sine A plus cos A is the same as cos A plus sine A. So this cancel this, the 2 cancel the 2, sine over cos is tan. Yeah. Nice with this?
Yes, sir.
All right, nice. So that's tan A. Okay, beautiful. You can't finish there though. You have to write equally right hand side. All right, so now the proof is done. They can write, I don't want you write a QED, when you write SOFT, soft, with a capital T. Nice. That's what we put right there. Now part C. Part C says using the formula for sine A plus sine B, show that if T is 2 cos theta, then sine n plus 1 theta times T sine n theta minus sine n minus 1 theta, them two they're supposed to equal each other. Now these are the trick proof them that I used to like when trick proofs used to make sense. All right. So we want to prove that this statement is in fact true. All right. So let's go ahead and do that. And they say using this, Marika. This is what they want to say use sine A plus sine B. All right. So let's see how we can do that now. So I'm just writing down what we need to show. All right. They said also to substitute T equal 2 cos theta. That's going to come in handy at some point. We don't know when yet. And we are required to prove RTP, required to prove sine n plus 1 theta, sine in bracket n plus 1 theta, and they want us to show that this is equal to T sine n theta, T sine n theta, T sine n theta minus sine n minus 1 theta minus sine in bracket n minus 1 theta. Now, Marika, read this now. If this is what you're required to prove, it said using this, using this. Now, there's no way we can use this if we're going to prove it this regular way. So in other words, even though this is what we're required to prove, look what we're going to do. We're going to do something a little weird. We're going to bring over the minus over here to make it plus. So we're going to rewrite this and say we're trying to prove then that the sine of n plus 1 times theta plus, when you carry over the minus become plus the sine of n minus 1 theta, we're trying to prove that this supposed to equal to t sine n theta. This is what we're actually trying to prove. Does that make sense then? This makes sense? This makes sense, Marika?
Yes, sir.
All right, so that's what we're trying to prove now. So nice. Now, Marika, look at this. Now we can use the formula. Remember what the formula said? The formula said the sum of two sines is twice the sine of half the sum times the cos of half the difference. Don't it? Twice the sine of half the sum times the cos of half the difference. So this is like a now. All of this is like a, and all of this is like a B. Yeah, man. All of that is like a and all of that is like a B. This is sine A plus sine B. So sine A plus sine B, Marika, remember it is the sine, it is twice the sine of half the sum. So I need to add up this now. I'm not that, I know it's a Sunday, so usually I'll be able to add these a lot easier, but don't know what's going on. But I have to actually just write them out like this, adding them. I know that this is n times theta, which is n theta plus n theta. That is 2n theta. And then This is theta plus minus theta that gone. So twice the sine of half the sum. When I add it, I would get 2n theta over 2. Then it is being multiplied by the cos of half the difference. The cos of half the difference now mean I need to subtract. Let's subtract them now. So if I were to change this to minus, this would be n times theta minus n times theta, that's 0. And this is theta minus minus theta, that's 2 theta. So that's 2 theta over 2. So now, Marika, what we end up get is, from this now, we end up get, put it back in black. This is 2 times the sine of, this 2 cancels this 2. So we get 2 times the sine of n theta. And this 2 cancels this 2. So we get times the cos of theta. Good. Now, Marika, look at this now. We can rewrite this as being equal to, remember that multiplication is commutative. So I can rewrite this as the sine of n theta being multiplied by, you see the 2? I'm going to multiply the 2 times the cos theta. So it's sine n theta times 2 times cos theta. But then what is cos theta? The question said use cos theta as t. 2 cos theta is t. So this is very easy because this is t times sine n theta. So that works out to be t times sine n theta. So actually prove it, Marika. So see it there, we get we prove. Actually show say sine n theta plus 1 plus sine n minus 1 theta equal t sine n theta, right? So you write this now, so that means that the sine of n plus 1 theta plus the sine of n minus 1 times theta is actually t sine n theta, and then you can actually subtract this from that side now and end up getting back the conclusion. So you can tell them hence, that implies the sine of n plus 1 theta, hence the sine of n plus 1 theta is equal to t sine n theta minus the sine of n minus 1 times theta. Nice. All right, cool with this? Cool with this, Marika? Are we cool with this, Marika?
Yes.
All right, cool. The reason why I asked is I noticed from the mock exam you left out the trig proof. All right, at the last question.
I ran out of time when I was trying to upload it.
Okay. All right. So good. Just want to make sure we're cool with these. So now you realize that you have to know all of the trig rules. You realize?
Yes, sir.
Good. So we did it that easy, but I think they should have put 3 instead of 2, but them say 2. Then it says, hence, show that sine 3 theta is this. Hence meaning using this knowledge up here. All right, hence. Now, look at this now, Marita. If you put n as 2, right? If you put n as 2, 2 plus 1 is 3. So it says hence, meaning I need to use that formula. So look at this, Marika. If we let n be equal to 2, let's put n as 2, Marika. If we put n as 2, following the formula, we're going to see we're going to get n as 2, 2 plus 1 is 3. So we're going to end up get the sine of 3 theta is equal to, put n as 2. N as 2 now, this is t sine 2 theta. T sine 2 theta minus, put n as 2 again, 2 minus 1. 2 minus 1 is 1, so get minus the sine of theta. minus the sine of theta. Now we're done, Marika, we're really done. Because guess why? Sine 2 theta now is 2 sine theta cos theta. So this will work out to be t times the sine theta, 2 theta is 2 sine theta, 2 sine theta cos theta, and then minus sine theta. Good. Now, Marika, look at this now. Look at this. You see this now? I can expand in the t and write it as, actually, I'm just going to factor out sine theta. If I factor out sine theta, Marika, I'm left back with 2t cos theta, 2t times the cos of theta minus 1. Now look at this, Marika. Didn't they tell you that t is equal to 2 cos theta? They told us that t is equal to 2 cos theta. So that means that 2 here and the cos theta here, 2 cos theta is t. So this becomes what? The sine of, this will become the sine theta times the 2 cos theta becomes t. So t times t becomes t squared. Oh, t squared minus 1. So that means that the sine of theta is indeed t squared minus 1 times the sine of theta. Easy, don't it? Easy. That too easy. So we don't even tell them QED again. We tell them soft. See it here? S, O, F, and then we'll put a capital T. Soft. Cool that, Marika? Yeah? We're cool?
Yes.
All right, so that's that right there. Now it says, hence, it says using the result from the third one, or otherwise, you can do it any way you want, Marika. You can go otherwise if you want, or you can use the result from part 3. Find the solution. We're going to do it both ways. So we need to solve sine 3 theta equals sine theta, part 3. So I'm going to split it in two, because we're going to do it the two-way then. So solving sine 3 theta equal sine theta. So over here is the hence. So this is the hence method. And over here is the otherwise. Otherwise meaning you can disregard everything them tell you and do it how you feel like. Otherwise. All right, so depending on the question, you know, you can do it any way you want. All right, so we're going to do it the two ways then. Sine 3 theta equals sine theta. Let us start with the hence. Starting with the hence from right here. Starting with the hence, sine 3 theta is t squared minus 1 sine theta. So you can replace this now with t squared minus 1 times the sine of theta from the hence, and that equals sine theta. Instead of say equal sine theta, bring over the sine theta and write minus sine theta and put say that equals 0. Yeah? Cool with that? Cool with that, Marika?
Yes, sir.
Then we can factor out a sine theta. Yeah, factor out a sine theta and we're left back with t squared minus 1, t squared minus 1 minus 1 equals 0. So if this is what you have, Marika, then you know says either this equals 0. So we can write down say either the sine theta part equals 0, either sine theta equals 0, or we know say our t squared minus 2 equals 0. Yeah, man, is either that equals 0 or t squared minus 2 equals 0. So you draw your circle, right? I want to say if the sine of theta equals 0, then we know it's either them here in these two quadrants. So now we take sine inverse of 0, sine inverse of 0. Taking sine inverse of 0, we end up get that theta equals 0. And the next answer you get is In this quadrant, it is pi minus 0, so you end up get theta also equal pi. Let's look at the answer from over here. From over here, you end up getting t squared is equal to 2. So when you square root both sides, you get t is equal to plus or minus the square root of 2. But Marika, what was t? T was 2 cos theta. Oh, that's what the question did say, don't it? Yeah, man, the question did say t equal 2 cos theta. So right here, so now we just put 2 cos theta equal to plus or minus root 2. So you end up divide both sides by 2. And so the cos of theta is equal to plus or minus root 2 over 2. Root 2 over 2. Then now, Marika, you draw your circle, you draw your circle, you draw your circle. And you want where cos it, you want everywhere. Because plus or minus, you want everywhere. But then you have to look back on what the question did ask. The question did say them only want the answer between 0 and pi. Pi, Marika, is half of a circle. So that means you can cut off the next half. Ignore down here, so you only want half of the circle. You want from 0 to pi to be your answer, 0 to 180. So you only want the first two quadrants. In the first quadrant, we know that we'd end up get theta is equal to cos inverse of root 2 over 2. Let's do that on the calculator. Cos inverse of root 2 over 2. Root 2 over 2. No, it's 45, but just to show it, no, it's 45 degrees. And 45 is pi by 4. So theta is pi by 4. And then in the second quadrant, theta will be pi minus pi by 4. Pi minus pi by 4 is 3 pi by 4. So those are our answers. Those are the four answers. Theta equal 0, pi by 4, pi, 3 pi by 4. All right. Cool with that, Marika?
Yes.
Cool with this? So those are the four answers. 0, pi, pi by 4, 3 pi by 4. Let's look at it the other way quickly. Now the other way, you know, so sine 3 theta is equal to sine theta. You can actually break it out now by saying, but sine 3 theta is a sine of 2 theta plus theta equals sine theta. And then what you'd have to do is use the compound angle, sorry, not double angle, compound angle, and expand it as sine 2 theta. I can't write theta, so I'm just going to use x as theta. Sine 2 theta cos theta plus cos 2 theta sine theta equals sine theta. That's what you'd have to do. All right, and then when you get to this step now, what you'd end up doing now is you'd have to do some more substitution. You can either replace, let me see, since this have the sine x here, you can bring over the sine x and write it as sine 2x cos x plus cos 2x sine x minus sine x equals 0. And then what you do, Marika, is you quickly realize that, oh, this way long here, you'd have to substitute sine 2x as 2 sine x cos x. Sine 2x cos x plus, yeah. Then you have to substitute sine 2x as 2 sine x cos x. So this would work out to be 2 sine square x, because sine 2x is 2 sine x cos x. So it would be 2 sines sine x cos square x. You wonder where I get the cos square from? I replace sine 2x with 2 sine x cos x. The cos x and the cos x become cos square. Then you have plus, you can replace this cos x now with, you can use either 2 cos square x minus 1 or 1 minus sine square. I'll use 2 cos square. So you use 2 cos square x 2 cos square x minus 1. Then you multiply it by sine x. Then you minus sine x. You equate this to 0. Minus sine x equals 0. Then now you continue from there. You work it out. Now actually the hence way really longer. I'm glad so we never bother do it. It's gonna take too much time. Can't bother. Alright, can't bother. Waste of time. Let's do it the hence in this case. That'll take too long. Alright, but this is how you do it otherwise. Alright, if you want to. Alright, either way is fine. But we can't bother with that. So this is what we get when we work it out. You can write down all the solutions. We get theta equals 0, or theta equal pi by 4, or theta equal 3 pi by 4, or theta equal pi. All right. Cool with this? Cool, Marika?
Yes, sir.
Nice. All right. Now let's go to question 4. Question 4. This was on the mock exam. Yeah, you remember this question?
Which one?
This question 4 was on the mock exam. So finally we're going to get to do it.
I don't think I did that one.
All right, so no problem. So now we're going to do it. It says the line x minus 2y plus 4 cuts the circle with center P at the points A and B. And it says we're supposed to find P, A, and B. So Marika, what they're virtually telling you is you have one circle. Cool, you have one circle. And put the circle here. So see circle here. And then say you have one line. Let me see if I bring the line over here, gradient negative. You have one line like this. And then tell us that the line is a secant to the circle. So it cuts the circle at 2 points. Not only does it cut the circle at 2 points, but this line is such that this line, it passed through the center of the circle. All right, so what they're telling you is find A, this would be A, 1 point of intersection, this would be B, and then Marika, once you find them 2 points here, P at the midpoint. That's not easy. That's all I'm asking you, that's not easy.
Yes,
Make
sir.
sense? Yeah, man. So why didn't we take on that in the mock exam? Yeah? So can you answer me, Marika, why we didn't finish that in the mock exam?
Because I had the internet problems, and then we had to upload it at a certain time.
Excellent. No, but what you can do, if you have an internet problem, just download the paper. Once you download the paper, you don't need to be on your computer the whole time. Once you download it, you just can do it. Just look at the screen, finish. Then when you finish, you upload. You get what I'm saying?
Yes, sir. I just didn't download it.
Yeah, you don't.
I didn't think, but then, I guess it just happens.
Yeah, you don't have to look at the screen all the time. Just download the computer and have it, download the paper. All right, so next time you can do that. All right, so this is it. Let's write out the circle now. The circle was x squared. Just need to look back at it. X squared plus y squared minus 2x minus 20y. X squared minus 2x plus y squared minus 20y. And then this is something. The constant was, I think it's 51 here, plus 51 plus 51. This equals 0. So now, Marika, we're going to solve them simultaneously. So this right here now, we can make x the subject. Making x the subject, x is equal to, bring this over here, 2y minus 4. That is x. 2y minus 4. Since this is x now, yeah, then in here, so now we're going to have, this is now 2y minus 4 all square minus 2 times in bracket 2y minus 4 plus y squared minus 20y plus 51 equals 0. All right, so let us blow through this now because those are just quadratic. Come on, quadratic. So this works out now to be 4y squared twice the product of the two, 8 times 2 is 16. This is minus 16y plus 16 is become minus 4y. 2 times minus 2 times 4 is 8 plus y squared minus 20y plus 51 that equals 0. Cool. Now, Marika, as we can see, y squared and 4y squared is 5y squared. That's 5y squared minus 16y and minus 4y, that's minus 20y. And minus 20y minus 20y, that's minus 40y. And looking at the constants now, we have 16, 8, and 51. 16 and 8 are 24. La 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 la. Is that so? My addition's a little off. Let me see. 51. All right. Let me just use the calculator. It's really sad, but that's how it is. It is 51. What did we say right there? 51 plus what? 51 plus 16 plus 8. 51 plus 16 plus 8. How did I not get 75? Oh my sweet Lord, that's 75. All right. Nice. Equals 0. So now, Marika, we can divide through by 5 and reduce to a simple quadratic 7y squared minus 8y plus 75 divided by 5 is, not using a calculator, that is 20, is that 25 or 15? 75 divided by 5. That's 15, all right? 15. So now we need to finish off this. Which two number we times them we get 15, but when we add them we get 8, that look like 5 and 3. So we can factorize now. We have y and y, 5 and 3. Signs are the same, but both of them negative. So minus and minus. So finishing it off right here, we have y equal 3 and y equal 5 here. We're cool with that, Marika? Cool?
Yes.
Now we just need to find x. Now plug in y as 3. 2 times 3 is 6. 6 minus 4 is 2. And then now plug in y as 5. 2 times 5 is 10. 10 minus 4 is 10 minus 4. Wow, 10 minus 4 is 6. All right, it's a bad Sunday. The addition part is not flowing. So the points then is 2, 3. And the next one is 6, 5. And I wrote y instead of x. So let me fix that. X. So those are the points of intersection. So Marika, what we did was we find A and we find B. We don't find P yet. So what that means is, I love give them a sketch, Marika. When you give them a sketch, you show them, say, you know what you do. See it, you give them a sketch, we show them, say, see it there, see it there. These are the line, these are the circle. And the line which is, this would be x plus set of positive gradient. So the line of a positive gradient. So let me take out a line. This is a line, right? We're giving them a sketch. And we have 1 point is 2, 3, and 1 is 6, 5. So here's our 2, 3. Here's our 6, 5. And now we want to find P, Marika. So to find P, this is A, and this is B. P is the center of the circle. Remember, that's what they said. They said, Marika, they told us P is the center with center P. If P at the center of the circle, this right here, so have to be P. But P is just the midpoint of these two right here. So if P is the midpoint, Marika, P is going to be 6. Well, 2 plus 6 is 8. So P is going to be 8 over 2, comma, 3 plus 5 is 8 over 2. So the center is 4, 4. That's 4, 4. That's one way you could have found P, Marika. Yeah, that's P. All right, that's P. Cool with that?
Yes.
All right, now let me see something. This is A, this is B. Did it say A and B cuts it at? Just want to make sure I did the right thing here. Find. Oh, it didn't say the line cut the circle passing through the center. It just told us P is the center. My apologies. P is not this, but A and B is correct, but P is not that. All right, my apologies. I read it wrong. It didn't say that the line. They didn't say the line passed through the center. They just said the circle with center P. All right, so my apologies. To find the center P, I didn't tell you this easy way, Marika, but I'm going to tell you an easy way now to find the center of a circle. Remember, I always tell you have to complete the square.
Yes, sir.
No, I was lying. There's another way. What you can do is, you see this right here? You divide the coefficient of the x by -1, by -2. When you divide the coefficient of the x by -2, what you're going to get in that case is 1, and divide the coefficient of the y by -2 again, and you're going to get 10. So the center is 110. That's a quick way of finding the center of the circle. P is 110.
Negative, you use -2?
-2, yes. All right. So P is the point 110. 110. So that line that I draw up there wrong, because enough will pass through the center. So come and just fix this.
So if you divide by -2, you get 10. It's not negative.
I divide -20 by -2, I get 10. Yeah, so that's the center. So P is the point 110. Now, if you don't like that method, Marika,
I like that method.
all right, now it's easy and shorter, but what that method doesn't do, it doesn't give you access to the radius. This method now, completing the square, where you would write this now as half it, you'd end up get x minus 1 all square, subtract 1, then you'd have plus, you'd end up have y minus 10, y minus 10. I know we love shortcuts, Marika, but I don't want to rain on the parade, but the thing is, this shortcut method never gives you the radius, all right? So minus 100, then plus the 51, and that equals 0. So in this case, it would end up so that when you complete the square, this is the other method that I prefer you to do. You have x minus 1 all square plus y minus 10 all square. Now the minus 100 plus 51 is minus 49. So we'll bring it over, we'll get equal to 49. So the radius is 7. That's the radius of this circle. So the center is 110. The center is 110 somewhere here. 110. This is 110. And the radius is 7. All right. So I can actually rub off A and B off of this circle because I don't put the points, right? I'm just going to redraw the circle. All right, so that's the same, that's P. So now write down all of the point and get them. P is 110, A is 23, and B was, I think, 6.5. All right, so that was what you were supposed to do for the mock exam. Easy, soft. Nice. Now let's continue. The next part now says, Marika, you have one other circle. Let's make sure we read the question good. It says the equation of any circle through A and B is of the form like this. And it says where lambda is a parameter. It says a new circle C with center Q. So tell me, Marika, you have one new circle with center Q and it passes through P, A, and B. So Marika, if the circle passed through Q, P, A, and B, we're good. Sorry. All right, so let's write down. I'm going to show you visually what they're talking about. So let me change the color. This is the original circle, right? The first circle we have. Let's call it C1. Them tell us say you have one next circle we pass through A and B. If you put on A and B on the this circle, all right, 2, 3 would be somewhere. Let me see. This is 1, 2 would be over here. 2, 3 would probably be somewhere down here. So let's say this is A. This is A. B is 6, 5. 6, 5 would probably be somewhere right here. This would be B, right? That makes sense? A and B here, so? This makes sense? So if you have one new circle now, Marika, where passes through, it's a pass through A, B, and P. Now, my sketch won't be so accurate, but it's pretty much like you have one new circle now, where I want to be like this, pass through A, B. I want to make it a new circle pass through A, B, and P. Trying my best to get it through all of them. All right, let's say the circle looks something like this, right? So it pass through A, B, and P, and it have one new center being Q. Then we'll find the equation of this circle pretty much now. This is what we're gonna end up though. You saw them bad? This bad, huh? Yeah man, this bad, Marika. Think about it. You have one next circle. Yeah, change the color to burgundy. Or change the color to burgundy. I'm gonna change the color to burgundy. But you see the circle I'm talking about now, right? That pass through P, B, and A, right? The smaller circle there, that's the new circle. And then tell us that that circle there, where passes through, them say the equation of any circle through A and B, a new circle with center Q passes through P, A, and B, it's of this form. Find the value of lambda. So first thing, Marika, is we can write
sure.
down.
Can you give me 5 minutes?
All right, let's continue now. All right, so the second part now it says, find the equation of any circle passing through A, B, and P, and it has center Q. Find the value of lambda. Now, Marika, if this is a circle right here, let's write that down. All right, so this smaller circle will have, it have equation x squared plus y squared minus 2x minus 20y plus 51. Then it's a minus lambda times something minus lambda times x minus 2y plus 4. So plus lambda times x minus 2y plus 4 equals 0. Now, Marika, if this new circle we have, right, let's call it C2. If this is a new circle C2, the one here C2, if C2, Marika, pass through any one of these points, P, A, or B, then that means it satisfies the equation of the circle. So what that means is, Marika, we can use any one of the points then to find lambda. Let's use P. At P being 1, 10, You can plug in x as 1, y as 10. You'd get 1 square is 1 plus y square, which is 100, minus 2 times 1 is 2, minus 20 times 10. 20 times 10 is 200, plus 51, plus lambda times x is 1, so you have 1 minus 2 times 10 is 20. Then you have plus 4, all of that equals 0. All right. So working out all of this, I can't bother going for the calculator to save some time. Going for the calculator, it is 1 square plus 10 square minus 2 times 1 minus 20 times 10 plus 51. That part work out to be negative 50. So all of that part here work out to be negative 50. Then we have plus lambda times what's over in this bracket. This bracket will work out to be 1 plus 4 is 5. 5 minus 20 is negative 15. So this work out to be 50 minus 15 lambda equals 0. So bringing this over here, we get 15 lambda equal to negative 50. And so lambda Marika is negative 50 over 15. Negative 50 over 15. If you want, you can simplify, dividing through by 5. This works out to be minus 10 over 3. That's lambda. That is lambda. Lambda equal minus 10 over 3. Cool? All right, nice. We'll call it this.
Yes, sir.
All right, now it says find the equation of the circle C. Now, Marika, this circle now we can find the equation. Now that you know lambda, you need to find the equation of this circle. So that circle, remember, it is given by x squared plus y squared minus 2x minus 20y plus 51. Then it said minus lambda, so it's now minus 10 over 3, because that is now lambda. Marika, we replace lambda with 10 over 3. So that's minus 10 over 3 times in bracket the x minus 2y plus 4. This is the circle, but of course we want to find the equation of it, so we're going to put it in standard form. All right, so Marika, just to not waste any line, 10 over 3 times x, that would make it be minus 10 over 3x. Then minus 10 over 3 times 2, that would make it be minus 200 over 3. And then the minus would make it be plus 200 over 3. Then 10 over 3 times 4. 10 over 3 times 4 would make it be minus 10 times 4 is 40. So minus 40 over 3. All right, so all I did was expand in lambda. Now, Marika, we're going to simplify. We're going to get x squared. Now, minus 2x minus 10x. You see this minus 2x here? 2 is really 6 over 3. This 2 is really 6 over 3. So minus 6x minus 10x is actually minus 16 over 3 times x. Then we can, that's our x term here. Then group up the y's then, plus y squared. Now you see this 20y is actually minus 60y over 3. So minus 60 minus 40 is minus 100 y over 3. Then we can add our constants. This is 51 and this is 200 over 3. 51 is actually 153 over 3. So that would end up being now 153 minus 40, that is plus 113 over 3 equals 0. You could actually leave it here and say this is a circle, but I want us to complete the square so it look better. Completing the square now, it would become x minus half this becomes 16 over 6. 16 over 6 square. And then we'll subtract 16 over 6 square. Then we have plus. We're going to get now y minus, we half it to get 100 over 3 divided by 2 is 100 over 6 square. Then we subtract 100 over 6 square. Then we have plus 113 over 3 equals 0. So almost done, Marika. We'll just simplify now. This right here would work out to be x minus 16 over 6. Remember, 2 into 8, 2 into 6 goes 8 times. 2 into 6 goes 3 times. So that's really 8 over 3 square plus this part now. 100 over 6 is really 100 over 6 is 50. So that would be 50 over 3 square. And that's equal to, we're going to work out these parts that I'm going to underline in black. We're going to put it in our calculator. Putting down in the calculator, we're going to get, so we're going to have 16 over 6 square plus the next part would have been 100 over 6 square. Then we minus, I think that was 113 over 3. That's 22225 over 9. This is now equal to 2225 over 9. Now, if you were to square root this now, I'm going to square root it so I know the radius. Square root of this. All right, that's not beneficial at all. I won't square root it. I'll just leave it at that. This is the circle. All right. That's the circle right there. That's the circle of C. That's the equation of C. All right. So we're done. This is this right here. Part 2. Nice. Now, Marika, it says now, find the distance PQ between the circles. Find the distance PQ. Now, Marika, you see why I'm going to go put it in a standard form? Now, it says find the distance PQ. PQ is this distance. The distance between the two center of the circle there. Don't PQ at that distance there, so? That's a PQ, don't? Right?
Yes, sir.
But we already know Q now. From this right here, we know Q. Q is 8 over 3, 50 over 3. So write down the coordinates, we know that P is 110. And we know that Q is the point. 8 over 3, 50 over 3. So by finding the circle in its standard form, make it easier to find PQ. So the distance PQ, we can tell them that that distance is equal to the square root of, remember it is x1 minus x2 minus x1 square, 8 over 3 minus 1 square plus 50 over 3 minus 10 square, and that's the distance PQ. You can just put that in a calculator. No issues. Let's put it in the calculator. The square root of, open bracket, 8 over 3, 8 over 3 minus 1 square plus in bracket, this is going to be 50 over 3 minus 10 square rooted, work that out. That is it, the distance between them. I did square root the whole thing, and make sure I put the square. Yeah, everything good. So that's 5 root 17 over 3. So the distance between PQ is 5 root 17 over 3. That's the distance between P and Q. Maybe you want to see it in decimal, so it's up to you. 6.87. So you realize that them fairly close. P and Q is fairly close. The distance between them is roughly 6.9 units. They're not very far apart. I know 5 root 17 over 3 look big, but realize it really small. All right, nice. The next part now, Marika, it says find the distance PM. Find the distance PM if PQ cuts AB at M. This sounds hard, but it's very easy. Let's look at what they're saying. If PQ cuts AB, look back here, so this is PQ. Them say if PQ cut the line AB at M. So first thing we need to do, this is PQ. This is PQ, Marika. If PQ cut the line AB at M, this is the line AB. This is the line AB. Let me draw it in burgundy. This is the line AB. And then if PQ cuts the line AB at M, this would be M right here, though. Where them intersect would be M, though. Right? Right, Marika?
Yes, sir.
All right, good. So if PQ cuts that line right there at M, find the distance of PM. Now that's easy. All I need to first do is find the line AB, find the line PQ, solve where the two of them intersect, then them intersect at M. Once we get that, we can find the distance PM. So let's do that. So now the line AB, Marika, first thing we're going to do is find the gradient of the line AB. All right, so the gradient of the line AB is rise over run. It's y25 minus 3, which is 2 over x2 minus x1. 6 minus 2 is 4. So that is a half. Oh, I'm so stupid. We don't need to do that. We already have the line that passed through A and B. Didn't they give us that to us? Let's look back at it. Sit here. The line passing through A and B. I was almost about to refine this line. This line was given to us, no? Yeah, so the line passing through A and B, we already have it, good. So already have that line put down right there. So already have that line put down. So the next part, this is part 3. So you can tell them line through A and B is line through A and B is, that line is given by x minus 2y plus 4 equals 0, right? Right, Marika? Yeah?
Yes, sir.
So now we just need to find the line through P and Q to give us that line right there. The line through P and Q, let's do it right here. First thing we need to do is find the gradient of PQ. The gradient of PQ, Marika, that's going to be equal to rise over run. Gradient of PQ, so Q had coordinate 50 over 3. I'm just going to put it in the calculator, all right? I knew that this is 50 over 3, 8 over 3, P is 110. I'm just going to put it in the calculator because we know to find gradient. Gradient of the line is y2, 50 over 3, minus y1 of 10. divided by x2, 8 over 3, minus x1 of 1. So the gradient of PQ is 4. It worked out pretty. The gradient worked out pretty. 4. The gradient of PQ is 4. Yeah? That nice, no?
Yes,
So we can use the point P, so the equation of the line is going to be y minus 10 equal gradient of the line 4 into x minus 1. That will simplify to be y equal 4x. That would have been 4 times minus 1 is minus 4. But when you bring over this over here, minus 4 plus 10, that is really y equal 4x plus 6. That is going to be 4x plus 6. All right, it down around here. So the line through P and M. So the line through P, M, and Q is, what was that again? Y equal to 4x plus 6. So now, Marika, these are the two lines I have. Let's just solve them simultaneously. So we can plug this one into that one to say x minus 2 times y, which is 4x plus 6. That is then going to be equal to, well, plus 4 equals 0. All right, why is it writing a little darker? Let's finish this. X minus this is going to become minus 2 times 4 is minus 8. That works out to be minus 7x. Then minus 2 times 6 is minus 12. Minus 12 plus 4. Minus 12 plus 4 is minus 8 equals 0. So bring this over to get x is then actually going to be, that look like negative 8 over 7. That's x, negative 8 over 7. Let's check it one more time. Minus 2 times 6 is minus 12. Minus 12 plus 4 is that? Yeah, so minus 8 over 7. All right, just to finalize it, make sure we got the equation right. 4x plus 10 minus 4. Yeah, 4x, that's good. All right, so that is x. Now we can find y by plugging y in this right here. So let's put that in the calculator. So now 4 times that x value of minus 8, 4 times in bracket minus 8 over 7 plus 6. All right, that's 10 over 7. So y is 10 over 7. All right, so y is 10 over 7. So now, Marika, this is our point M. All right, so that gives you the point M. M is actually the point minus 8 over 7, comma 10 over 7. That's where the two lines intersect. Since this is our point M, now we're able to find PM. So you got 2 out of the 4 marks now. So PM, Marika, we use the length of a line formula. It's a square root of x1 minus x2, x1, which is minus 8 over 7, minus x2, the x value at p is 1, square, plus y1, y value is 10 over 7, minus y2, minus 10, all square. Put that in a calculator, you get PM. It's really that easy. That's a length of PM. Put modulus to show a length. All right, easy. So let's put that in our calculator. That will be PM. That is the square root of, in bracket, minus 8 over 7 minus 1 all square plus, next bracket now, we have, this is, what was that again? 10 over 7 minus, the y value was 10 all square 15 root 17 over 7 or 8.83. 15 root 7 over 7. That's the distance PM. 15 root 7 over 7. That's the distance. And I forgot to write the word units. All right, length is in units. All right, that's the distance PM. Cool it is, Marika?
Yes.
Cool. All right, now next part now it says, all right, not yet there. It says a curve is given by the parametric equation x equal 2 plus 3 sine t, y equal 3 plus 4 cos t, and it says find the Cartesian equation of, show that the Cartesian equation of the curve is this. So we can do that right here. First thing we need to do is make sine t the subject. So we know that making sine t the subject, we'd have x minus 2 over 3. That would be sine t. Yeah, sine t would be this. And now we'll make cos t the subject right here. So we'd end up get that cos t would end up be equal to, bring this over, we get y minus, carry this over, y minus 3 over 4. That's what we would end up get. No, Marika, but we know one thing. We know that sine square t plus cos square t, we know so that equal 1. Sine square plus cos square is 1. So since sine square plus cos square equal 1, if you're to square this, Marika, you'd end up get x minus 2 all square the numerator, over, when you square the denominator, 3 square is 9, plus the cos part now become y minus 3 all square over the 4 square is 16 and equal 1. So that easy. 3 marks the easy done. That easy, right?
Yes, sir.
Easy 3 marks. Now the next part now says show that every point on the curve lies within or on this circle. So to show that every point lies within this circle, let's start with what we know. This is what we know, all right? So starting with what we know is that we have the circle x minus 2 all square over 9 plus, I think this was y minus 3 all square over 16, all right? And that is equal to 1. Now, Marika, look at this. If we were to multiply through by 9 times 16, I think is that 144? Let me check. 9 times 16. 9 times 16. That's 144, I was right. So if we multiply through by 144, right, look what is gonna happen. If we times through by 144, that gets rid of the 9 right here. So what we're gonna end up get is 16 times x minus 2 all square plus 144 over 16, Marika, is 9 in bracket y minus 3 all square, and this is ending up equal to 1 times 144 is 144. Pull it this. Pull it this, Marika.
Yes, sir.
All right, now that you get this now, Marika, what we want to do is we're actually just going to show that this is what's known as an ellipsoid. All right, it's an ellipsoid, meaning it's almost like a circle, but one side longer than one. A circle of a radius, right? So this length equal to this length, yeah? But an ellipsoid, how it behave is probably one side can look, if I'm just dividing it into one side look like this, the other side look like this. That's an ellipsoid, all right? So it don't have a radius. So now, there are many ways you can show that. Let me see what we're trying to show. We want to show that every point on the curve, every point on this curve lies within this circle, all right? Now, in order to do this, we really want to left back with x minus 2 all square plus y minus 3 all square equal 25. So pretty much we want to show that every point in this region will also satisfy that region. All right, so let's see how we can do that. In a case like this now, I'm going to expand and simplify and show that every point on the circle that I expand is going to be in the other circle. So expanding and simplify, I would have 16 times in bracket. This is x squared. Let me just multiply out the 16 one time. Why waste time? All right, so this is going to be 16x squared minus twice the product of the two, that's 4x. 4 times 16 is 64x plus, this is then now 2 squared, which is 4, plus, this is then now, 9y squared plus, this is then now 6 minus 6y, and 6 minus 6y times 9 is minus 54y. And Marika didn't even correct me to say, sir, 16 times 4 is 64. It should have been plus 64. All right. Plus, twice the product of the two. 3 squared is 9. 9 times 9 is 81. And that's equal to 144. So what we end up getting now is this right here, which is 16x squared. Bringing over this number now, bringing over the numbers, minus 64x. This is then plus 9y squared. This is then minus 54y. Now look at this, 64, 81, add them there together. 64 plus 81, if you add them, 64 plus 81, that gonna give you 145. Cool. If you add them here, you get 145 equal 144. When you bring it to the other side, it's gonna equal to -1. Marika, does that make sense? How I get -1 right here?
You the constants, so you bring over yeah 81. This is 100 and negative 144 plus 81, right?
I bring over the 64 and the 81.
81, yeah.
All right, and then I subtract it. That's how I get the -1. Good. Now, bear this in mind, look at this, Marika. All right, this right here is the equation of this. Now, what I'm going to show you, I need to show that this equation is less than the other circle. Now, this is what I'm going to do. Now, so the other circle now that them give you, I'm going to expand it and show you so that one bigger. Look now, because now we have x minus 2 all square plus y minus 3 all square. This is equal to 25. If I were to expand this, I would get x squared minus 4y plus 4, and that is now plus, this is now y squared minus 6y, and this is then equal to, oh, plus 9, sorry, plus 9 equal to 25. Now, Marika, pre this now, pre. This circle right here will end up get x squared. Why I put y here? So that should have been minus 4x. Minus 4x, it shouldn't be no y, this will be x. Plus my y squared minus my 6y. Look at this now in America. You see 4 plus 9 are what? 13. So when I carry it over this, so 25 minus 13 is 12. Do you see how I get 12?
Yes.
Good. Now look at this now in America. Look, look, look. You see this circle right here, so? Not circle. You see this ellipse right here, so clearly this, we can tell them, say, writing out all of this. This is one way you can tell them, so see there, see your 16x squared. Your 16x squared minus your 64x plus your 9y squared plus your 9y squared plus, this was, oh, not plus, minus 54y, which was equal to negative 1. And this is clearly less than, let me write it in a different color now, clearly less than x squared minus 4x plus y squared minus 6y, because this one equal 12. Does that make sense, Marika? That circle is less than this one. That makes sense?
Yes, sir.
And so since this one less than this one, hence, remember that equation that we did start with, all of this right here, remember was x minus 2 all square, hence x minus 2 all square over, that was 16, plus y minus 3 all square over 9. I think I'm writing it down wrong. X minus, or over 9 and over 16. This part was over 9. This part was over 16. Hence this right here. Hence this part, which ended up being equal to 1, is definitely less than. You can even put less than or equal to your x squared. This circle, which was x minus 2 all square plus y minus 3 all square, which is 25. So then you can tell them, say, hence, all the points in this ellipsoid is in this circle. You can tell them that as a conclusion. Hence, all the points in the ellipsoid would be in that circle. All right, so it is true. All right, so this was a different kind of question. This was a different kind to prove, don't it? Right?
Yes, sir. It was a bit difficult.
All right, so you just see that you have to be aware of all of these stuff. That's just pure math. You have to be aware of so much stuff. All right, now Marika, we're gonna move a little bit